And now the question is, what should one say to the neuroeconomists in order to crash that opposition of the neoclassical economists? And this is what I'm trying to do here, recommendations for neuroeconomists. Given these core reservations of economists, how should neuroeconomists proceed? And what sort of arguments could be successful in converting standard and behavioral economists towards more openness regarding neuroeconomics? Given these, I think, very well-founded objections, they don't have to be the final truth, but there are certainly strong arguments and they have some plausibility. And I shall give 5 recommendations to neuroeconomists, which are then meant here in class not as recommendations really, but sorts of analysis. The first recommendation is that one should be aware in this discussion between economists, neoclassical economists, and neuroscientists that there is some sort of tension, or at least opposition, tension between prediction and explanation. And sometimes it seems to me that there is an ambiguity in standard economics regarding predictions and explanations. Rhetorically, they are often treated as if they were just the same, but they are not. If you, for instance, analyze Friedman, he mostly speaks about predictions, but sometimes about explanations, and that you don't know, does he see that there is a difference? It's not clear. And I see that in other papers, also in economics, it seems to be economists are not very, very clear about that. And they tend, to equate the two. Now, as in the other sciences, predictions is a logical notion and is therefore comparatively uncomplicated. Namely, a prediction of a theory of a model is something that can be derived from the theory or model, and it does not imply ex ante, right? It's just something you can derive from the model. So it's a logical question. A prediction is something you can derive from the model, period, right? So this is comparatively simple, right? And therefore it's simple to speak about predictions. An explanation tells you why something has happened, and very often in causal terms, not necessarily, but very often in causal terms. So one is a logical thing, something you can derive, and the other thing is a causal thing that, of course, you need for science policy. We talked about that in macroeconomics. So there is a real difference between the two. It's also important to see their independence or partial independence. There are predictions that are not explanatory. For instance, prediction based on indicator laws, such as that barometer change will lead to weather change. That's a predictive law you can use for prediction, and it's an indicator law because it tells you an indicator for weather change, but it's of course not the cause. It doesn't give you a causal connection. And there are also explanations that are not predictive, namely all these explanations that historians usually give. They're always in retrospect, but you can't use them for predictions because the cases are all different from each other. So explanation and predictions, they are related, sometimes they are equal, but there are also cases in which they are not. And as far as I can see, roughly in first approximation, economists are rather loose in talking about predictions and explanations. Now, economists may speak of explanations, but when methodologically pressed, they often retract to predictions of choice data. The causes of preferences are irrelevant. It's only the predictive power that counts. That's the normal, I think, as far as I can see, roughly speaking, the normal state of affairs in neoclassical economists. And if you look back, then this attitude goes back at least to Milton Friedman in the early 1950s. Going back is now a little careless here. I'm not claiming this is causal, but this may just be, a strong current in neoclassical economics, and Milton Friedman is just one of these representatives of that current, and you find it in the paper there. And it may be, but this is now a speculation, it may be that this attitude regarding predictions is probably not just a historical remnant, from positivism. It probably serves important functions of economics as a unified discipline. Because if you do not argue with other parts of economics about causality and only about predictions, then you eliminate possible disagreements about explanations across all subdisciplines of economics. And there, really different subdisciplines of economics may really disagree, but once you say, that's not our main business, the causality stuff and explanation. But when we say, yes, we can use microeconomics to make predictions, then the basis for agreement is possibly much larger. So it may be there may be a functional role for that, rather humble stance here of saying, all we do is make predictions and explanations perhaps from time to time, or we don't talk about them, or whatever. So this may be the case. I say this is speculative, but it may be that this is something important, because what I've seen in many economists, that they are really proud of some sort of unity between the different parts of economics, which is stronger than in the other social sciences. This is why I came up with the idea of orientational paradigms as well. So there may be something behind that, but I say this is tentative, speculative, okay. But it is important, because it's really different in the natural sciences. In the natural scientists usually distinguish between predictions and explanations for methodological reasons. Roughly, predictions are used to test theories and models, and theories and models are used to explain phenomena. So if you look in the natural sciences, typically, in the vast majority, they really want to explain phenomena, not only predict, not only have theories from which they follow. And in order to test these theories and models that they are using, you must use predictions and then test by the predictions the models. But the primary use of the models and theories is in order to explain phenomena, right? And I see that when you read these, some of these neuroscientific, neuroeconomic papers, then you see how strong these scientists, the neuroscientists, really tend to explain things. And this is something which is different from the attitude, typically, as I could see at least, from what neoclassical economists do. Therefore, natural scientists and standard economists may be sometimes at cross purposes, because for the neuroscientists, in the back of their mind, they always want to have explanations, and if you press the economists in the back of their mind, they want to have predictions. And that means, if that doesn't become explicit, that they are at cross purposes. And that has the following consequence, that microeconomists, neoclassical of course, are only really impressed by the predictive power of a hypothesis or a model of a theory, much less by its explanatory power. So this is what they stress. And therefore, they are at cross purposes, because the neuroeconomist is really impressed by the explanatory power, much more than by the predictive power. And the neoclassical economist functions differently from that. So, for instance, if neuroeconomists introduce new neuronal variables, economists, neoclassical economists, of course, will accept them only if they have novel predictive power. This is really the litmus test. If they don't have predictive power, they say, no, we're not interested. Whereas neuroeconomists may like them because they have explanatory power, right? So it just depends what goals you have. And there, I think the goals of neoclassical economists and of neuroeconomists are not equal. Again, one has to be careful and watch and note that economists do not in principle object new non-economic variables. Economics is, in the course of its history, quite open-minded. I'll give you an example in a second. As long as they understand them and they have novel predictive power for economic variables. Economists are open, and here's a really extreme example. When I stumbled upon it, I couldn't believe it. So economist William Stanley Jevons, a very, very famous economist in his time, introduced the sunspot theory of the business cycle. Right? Something which looks completely absurd. He just observed that the business cycle, with its 11 years, has parallels to the sunspot cycle. And you say, what the hell has that to do with each other? Nothing, what the sun is doing, right? But people said, well, if we can use it for predictive purposes, sure, why not? Well, we now know there's a causal mechanism behind that, because the sunspot circle influences our weather conditions. And if you look at the time here, we are talking second half of the 19th century, the economy, wherever that was of course dominated by the primary sector, right? So 80% was primary sector, and the primary sector is, of course, agriculture is dependent on weather conditions. So it's not implausible that there is a connection because the weather conditions is connected to agriculture, and this is, of course, the main ingredient in the business cycle. So it's not completely absurd. But even without knowing that, if it's predictively valid, economists are, in principle, I think, as from what I can see, open. Because like all scientists, economists are opportunistic. Whatever you can use, to fulfill what you want to find out or what you want to produce, you use it. So if you use sunspot cycle to make good predictions, here we go, of course we use it. Okay. All right. So this is the first thing. The second, distinguish between predictions and explanations. The second recommendation is neuroeconomists should make up their minds whether they want to contribute to the standard or behavioral economics tradition or not. So make up, if you are an individual, and what do you want to do? Or you want to criticize and change the standard or behavioral economic tradition, or if you don't particularly care about standard or behavioral economics. You've got to define where you want to be vis-a-vis standard economics, because on that depends what you're doing and how well it will be received by the standard economists. The borders between these alternatives may not be entirely sharp. And now the difference makes, in that sense, because for these three cases, I shall give different recommendations. So if you are a neuroeconomist and you want to be successful, make up your mind what you want to do regarding neoclassical economics, and then I give you recommendations what you may do. So the first recommendation is to those that want to contribute to the economic tradition, and there are two possible dangers, and you find them in the literature. And danger one is being pushed in the mere inspirations corner, which is a second-rate place. So standard economists will, under certain circumstances, I explain in a second, tell you, oh, thank you very much, this is a wonderful inspiration, right? But giving inspirations is not publishing papers in the top journals. So, and I explain that to you, how you can be pushed into this mere inspirations corner, again by an analogy and again by a fictitious meteorology, right? Imagine we have a meteorology with the following aim, namely only to predict weather changes, delta W, weather, from barometric changes, delta B. So we measure the barometric changes, and the aim of that meteorology is only to predict weather changes on the basis of these barometric changes, right? This is what this meteorology wants. It only wants to predict. Now let's assume he is a physicist, very clever physicist, and he says, oh, wait a minute, let's open the black box, namely by investigating the causal mechanism that explains the correlation of delta B and delta W, right? This is what a physicist would say. Oh, that's interesting that there is this connection, but I want to understand that, so I got to find out what's the causal mechanism that makes these predictions possible. And as we see that this is not immediately, the barometric changes are certainly not the causes, or what the barometer is doing is certainly not the cause of the weather change. The physicist will say the following: if we have this delta B and the delta W, we've got to find a mechanism that on the one hand produces causally delta B, the barometric changes, what you see on the barometer, and produces causally the delta W, the weather change. And that then is an explanation, why delta B and delta W are correlated, right? And this is, of course, not what the meteorologists would be doing. They just want to see the correlations between delta B and delta W. But the physicists say, no, wait a minute, I want to understand what is happening here. What's the causality involved here? So let's further assume that on this basis, the physicist is even able to predict a novel barometric change leading to a not yet observed or not yet investigated weather change. So a novel prediction is that physicists doing, because by understanding, this causality, so what will these fictitious meteorologists, how will be they reacting? Well, they will do the following. The meteorologists will test this special relation, delta B star and delta W star, and if it's correct, they don't trust the explanation. They test it by their own means, and then they will say, sorry, I'm not interested in your causal mechanism, but thanks for the inspiration, namely the inspiration to measure delta B star and delta W star, right? But when it comes to believing that this is a correlation, these fictitious meteorologists, they will stick to their own method and say, we know what we are doing. We know how to measure that. And okay, we didn't have the idea yet to measure that particular delta B star. Oh, thanks very much. Yeah, that we should measure it. And here we go. And for the validation of the relation in that particular case, they don't need the causal mechanism. And they are not interested, given the aim of that fictitious meteorology. And you see, of course, immediately this fictitious meteorology has some parallels with the neoclassical economics. When you say, all what we want to do is we want to predict choices on the basis of all the choice data, and we want to organize that in that way. And the causal mechanism, the causes of preferences, are not our interest. Right? So if you find out something by making some sort of causal analysis, wonderful. But for us, it's only inspirational. right? The same way that this in this fictitious meteorology. So this is a danger that you as a neuroscientist, you are trained of investigating causal relations, then you think, oh, I can contribute something very important, and you misjudge how your possible audience, your potential audience, the economists will react, because they say, we are just not interested in your causal mechanisms, right? It's none of our business. Economics is a different discipline. Okay, now the second danger, and that's even a bigger one from what I saw in the literature, is that you do not really contribute to the tradition as a neuroscientist, but exploit results from experimental economics for neuroscientific purposes, and economists will probably show little or no interest. Right? And I give an example here. An example is a fairly famous paper by Sanfi and others, The Neural Basis of Economic Decision-Making in the Ultimatum Game, published in Science, 2003, 3,400 plus Google citations in 2019. So what they did is they played the ultimatum game, well established by behavioral economics, put people in the in the tunnel, and then investigated what's the brain doing during the ultimatum game. And then they analyzed that. And now, what does the standard economists learn from that paper? That their emotional centers were, having showing activity and so on, so you can investigate how the subjects are what the subjects are doing, what the brain is doing during the ultimatum game, where people think, oh, that's unfair, blah, 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 and emotions and all of that. So now, what does the standard economist learn from the paper? Well, I guess nothing, because the behavior of the participants in the ultimatum game is an anomaly to standard economics anyway, right? And people knew that, they knew that before. Right? So are you interested in how this anomaly is generated by the brain? Not really as a standard economist. You say, yeah, we know that descriptively here, our standard economics doesn't really work. And what the brain is contributing to that not working is not really important. What does the behavioral economist learn from the paper? Well, I guess very little, because they already know that emotions play a role in the decision process. And psychologists can find that out very easily. You watch these people playing the ultimatum game, you talk to them, they get excited and they say, what an idiot my partner is, how unfair, and shouting and everything. So also the behavioral economists don't learn anything from that experiment. What do neurobiologists learn from the paper? A lot. It's wonderful for them, great progress, because they can decode a well-defined behavioral situation in neurobiological terms. They understand the mechanism underlying the behavior. So for them it's wonderful, but what are they doing? Now, I think this paper what are they doing? That is representative of a specific class of neuroeconomic papers. They don't display a substantive interest in economic questions. They are not investigating that case because it's economically interesting. No, they investigate that case because it's a well-defined behavioral situation where you have reproductive phenomena, so it's all prepared for you, and you just go there and say, let's look how it works in neural terms, right? In neuroscientific terms. So you don't want to really contribute to the tradition of economics, but you're just taking from that and exploit it for your own purposes. So this is what happens here. The interest is purely methodological. Experimental economics provides many examples of well-defined human behavior, and neurobiologists analyze them without really contributing to their economic content. Right? That's similar when you investigate the pack hole situation as a material scientist, right? And say, oh, where does this solidity come from? That may be interesting for you, but those people who are interested whether the pack goes through the hole or not are not interested in that. And you are just exploiting a well-established and well-investigated situation, but you're not contributing. So this is, I think, what some neuroeconomists at least underestimate. They're exploiting the economic tradition and they do not contribute to it. So they should not be surprised if the economists say, look, what you're doing is not useful for us. Right? This is the situation. Okay. Now, this is for those who want to contribute, and now here's the recommendations if you want to change an economic tradition. If you want to criticize and change an economic tradition, there's a two-step recommendation that has proved highly successful in the history of many sciences, including economics. So, it's not easy to change such an inert thing like a scientific tradition, but we know that this happens from time to time, and we can learn something from that. So the step one, if you want to change this tradition, is develop a known anomaly into a significant anomaly, right? So first I tell you, a mere anomaly is something that contradicts the expectations derived from standard scientific theory and practice. So you have something, an established standard theory and practice, and sometimes, you know, you have certain expectations, and sometimes these expectations are not fulfilled. Your measuring apparatus doesn't work, you don't get the results or whatever, and it's a nuisance, and every science always has anomalies. They are not taken very seriously often. Some people may work on them, others leave them for the future. They say, yes. So for instance, in quantum mechanics, it's still not clear how the measurement process functions. Everyone knows that for the last, well, now it's almost 100 years. People know that. You don't understand that, but don't work on it because you never come back, right? Leave it to the philosophers or leave it for the future. So this is known, and it's in other disciplines as well. There are countless examples where you have these anomalies in the really solid sciences, and people just say, we don't know what to do with them, but let's see what's happening, right? So they're not alarmed, really. The difference here is between mere anomalies and significant anomalies. Namely, significant anomalies are anomalies that for some reason call into question the standard scientific theory and practice. So there may be things happening that alarm you, that there's anomalies contrary to your expectations, but in a way that you are alarmed and say, damn it, isn't that a sign that something is deeply wrong with our theory? And they are called significant anomalies. This is coming, of course, from Kuhn's theory of scientific development. Now, unfortunately, there are no fixed rules about what turns a mere anomaly into a significant one. Historically, we can see that, people had anomalies, and then they became later significant anomalies, and then being the source of turning some established theory over. And that's very interesting how it works, but there are no fixed rules. And that's very important, scientists may substantially disagree about the status of an anomaly. So especially older scientists, more familiar with the older theory, may say, sooner or later we will deal with that. And younger, revolutionary people may say, wow, now we've got something, we can kill the old theory, and are quite enthusiastic about it in their judgment. They have both arguments, but it's really the case that there are no decisive arguments. It's a question of time how things develop. Okay, and here's an example that shows you that this turning of mere anomalies into significant anomalies is something that's a fundamental and important part of the economic tradition. And the example is prospect theory, and there are many other examples of the same sort. Kahneman and Tversky, 1979, begin their paper with a well-known anomaly, namely Allay's paradox. It was introduced in 1953, 26 years before prospect theory, and Allay's paradox was well known in economics. So the better economists all knew of Allay's paradox, and they said, yes, it's a paradox. Yeah, people do not behave like neoclassical theory postulates. Yeah, very strange. Yeah, so what, right? They left it somewhere and went on doing productive things, and building, models with all what was involved. Now, Allay's paradox is, in a sense, a counterexample to expected utility theory, but it was apparently taken as a mere, that means non-significant anomaly. People knew that, and they said, yes, that's strange, but they didn't panic. They just said, yeah. So, what Kahneman and Tversky do, and I'll read the paper again, hopefully, Kahneman and Tversky transform this anomaly into a significant anomaly. How are they doing it? By giving 11 further examples in all of which expected utility theory is violated. That's the trick. If you ask yourself, wouldn't be 3 examples enough? Well, for logical reasons, perhaps. But if you really want to have an impact, you show there are 11 or 12 altogether different anomalies with which expected utility theory is confronted. That's the rhetorical strategy, and that proved to be extremely successful, as you all know. Right? So they show this is not just an isolated incident where you can say, oh yeah, what shall it be? No, it's at the center of a cluster of anomalies, all of which are somehow counterexamples to expected utility theory as a descriptive theory. So people behave irrationally. And so something is going on here. And why so many examples? Because they show that Allay's paradox is not an isolated incident that can be pushed away. It is a significant anomaly at the core of similar problems. That's the core of this rhetorical strategy that Kahneman and Tversky developed so masterfully. And as I told you already, I'm an absolute fan of that paper concerning the rhetorical strategy. This is just an absolute masterpiece. Okay. By the way, similar example, also Fair and Schmidt, the most successful paper of Fair, used the same strategy. And Fair told me also in other papers he's doing the same. Push the anomalies, remember that Thaler's program, push the anomalies, show where the anomalies are, and from there you go to the next level, developing alternatives. And that is then step 2, develop an alternative model that can deal with the significant anomaly and is, at the same time, as conservative as possible. That's a very, very important advice. If you want to be a revolutionary in science, be as conservative as possible, as revolutionary as necessary, but as conservative as possible. Why? The more conservative you are, the easier to understand and potentially plausible your theory is. If you're too revolutionary, people will say, I don't know what that is, I don't know what to do with it, no, I hate it, right? But if you are very conservative, and then you can understand that. An example is, again, prospect theory, and they are really, again, this is absolutely masterful how they do it. Kahneman and Tversky introduced 3 new variables whose relation to well-known variables from neoclassical economics is transparent. So overall value replaces expected utility, decision weight replaces probability, and subjective value replaces outcomes. And it's quite obvious how these are related, and the formula then they get for what they want to have for expected utility is replaced by a formula for overall value with the same bilinear form, right? They just change from Latin letters to Greek letters, right? And then and then they give you diagrams which you can immediately understand as an economist what the deviation of that new theory is from the neoclassical theory. So the exposition is also masterful. You have no problem understanding what's going on, although the conceptual step is gigantic, going away from these preferences as more or less mathematical abstractions now to something much more mental concerning really motives of people. So, and then the mathematics, even the same bilinear form. So the neoclassical economists don't have to learn a new mathematics, which is also an investment. That's, of course, you think about it, whether it's a good investment or not. So the summary of the recommendation 4 is then learn from behavioral economists how to effectively criticize the mainstream economic tradition. This is what I tell those neuroeconomists who want to really attack the tradition. If you want to be successful, take this strategy. That's the only one that's known to be successful if you can execute it, if you find these anomalies and can find that they are significant. Now, the last recommendation is this one. If your neuroscientific research does not make any substantial contact with standard or behavioral economists, just try to publish it in Nature or Neuron or Science. These are the top journals, and you can publish there. And if you don't have interest what the economists say to your stuff, publish it there. It probably won't get you a job in a traditional economics department, but it may otherwise be useful. You may get a job somewhere else, right? And here's an example. I mean, no one of these authors, I think, looked for a job. Oxytocin increases trust in humans. It's a very famous Nature paper from 2005, Ernst Fehr being one of the co-authors. It has no direct connection to specific economic models or theories. It just starts from the obvious truth that trust is socially and economically important, and asks about the biological basis of trust among humans. Right? And it shows then that this single molecule oxytocin increases trust. So it's something important, but there is no explicit connection to anything, any economic model or anything. But they publish it in Nature, and the result was 3,600 plus Google citations in May 2019. So it's really a big, fat paper, and if you've got that in your vita, very fine. Well, the neoclassical economists will say, we won't hire him or her because there's nothing to do with economics, right? But it may be useful for other parts of other careers. So you've got to be careful there, although there is a loose connection to economics, and many empirical investigations have followed that with closer contact to economics, but that in itself is, although it's somehow economically relevant, has no direct connection to the economic scientific tradition. All right. So the conclusion is this. If neuroeconomists want to make serious contact with the economic tradition, if they want it, it's not necessary. You can do other things, but you won't get a job then in economics department. Neurovariables must be more than promises of an enrichment of economics. And some of the literature is of that kind, that the neuroeconomists say, yeah, we will enrich the economic tradition and blah, blah, blah. And then the classical economists will say, I don't believe you that you enrich it, because it will be irrelevant, it will be at best inspirational, and you do not understand how neoclassical economics is functioning because you're asking the wrong questions, right? We are not interested in courses for preferences, all that. We don't want to know that, right? And therefore, it's not interesting. So you must be more than. It must be more than mere correlations with economic variables. Then you are possibly pushed into this mere inspiration corner. If you just correlate something, then the economists will say, yes, possibly useful as inspiration, but not more, right? We can falsify and verify our stuff ourselves. We don't need your apparatus. We don't want to learn that. It's not useful for us. It must be more than mere correlations, and in the optimal case, it must produce novel predictions about choices. This is what economics is all about. And if you do not produce novel predictions about choices, novel predictions, right? It must be predictions that the economists themselves, with their toolbox, were not able to do, but you as a neuroeconomist using particular tools that from the neuroscientific toolbox, that you can make predictions about choices. And if you are successful with that, then I can probably guarantee that the economists will be listening if they are interested in what you can predict about choices they cannot predict. And as far as I can judge from what I see as an outsider, that I do not doubt that many economists will be open and say, okay, if we get something new for our questions, wonderful, let's get it, right? Okay. So these are my recommendations for neuroeconomics. It's a very interesting philosophical, so to speak, problem, this debate between neuroeconomists and neoclassical economists, and it's far from clear what is happening here. Ernst Fehr once said, he told Gul and Pesendorfer that they had won this battle, in this particular situation, but Fehr thought they will not win the war. Namely, in the longer run, if the neuroeconomists are able to produce what I said here, namely novel predictions about really economically relevant variables, they will have a point. But I haven't found so far really the smashing paper that would convince the neoclassical economists. All right, we have 2 more minutes. If you want to ask questions or make comments, you may do so now. If that's not the case, then please write me about recommendations, what I should improve in this class. I thank you very much. Those who are steadily present here, I saw that you are interested. Please give me feedback that I can better judge that. I wish you a wonderful time now for the time outside of the term, and I'll see you again, I guess, in a month or so when we have the written examination. Good luck. Okay, thank you very much.